So finishing up with muscle atrophy with no nerve stimulation, no exercise, again, like if your arm or leg are in the cast, or aging with no use or minimal use, your muscles will get smaller and weaker. Let's go into muscle fibers in terms of types of skeletal muscle fibers. So a muscle is made up of muscle fibers, but they actually are not all the same, especially the way they utilize ATP and how fast or how slow they contract. Excuse me. So fast fibers are also called white fibers. They're the most abundant in our muscles. They fatigue relatively quickly, but they are fast twitch. They are fast fibers. They use anaerobic metabolism that causes lactic acid buildup. In other words, the ability to generate ATP without oxygen. And they utilize ATP from the initial breakdown of glucose through a process called glycolysis. So they're quick twitch fibers. We find them like in our eye muscles, have a higher percentage of them, and in muscles of sprinting athletes that do well at fast events like 100-yard dash, for example. Their leg muscles will have a higher percentage of fast fibers than, say, long-distance runners. And they're called white fibers because they have a lighter color appearance than other muscle fibers. Hence the term white meat. They have relatively little myoglobin, which is that oxygen-storing protein. Slow fibers or red fibers, these are fatigue-resistant. They use aerobic metabolism or oxidative metabolism, utilizing oxygen to generate abundant amounts of ATP. They have long, slower twitches or contractions, so they're more efficient in that sense in terms of fatigue resistance. And our postural muscles in our body that we don't really ever sense them getting fatigued have a high percentage of the slow fibers or red fibers. And then endurance athletes that say can run the mile or marathon, their muscles will have a higher percentage of slow fibers or red fibers versus other folks. And they have an abundant amount of myoglobin, so the fibers are darker, redder in color, hence the term red meat or dark meat. And then intermediate fibers, they're the least abundant. They are intermediate resistance to fatigue versus some of the other muscle fibers. Relatively little myoglobin, so they're not that dark. And the number and type of fibers is genetically determined. And you can think about that. Think about, maybe grade school or high school. There are always some kids, athletes that were just quicker and faster than the others. And there are always some that are like simply stronger and more powerful than others. And that's because their muscle fiber types and percentages within their muscles is genetically determined. So a person who's relatively thin and quick, try as they might, they may not be able to pack on as much muscle mass as a student or person that's maybe not as fast, but stockier in build and more powerful. So, for example, long-distance runners that are really good long-distance runners are not going to be as good sprinters as really good sprinters, and vice versa. Long-distance runners can get fast, and sprinters can build up the endurance, but, the best long-distance runners are not good sprinters, and vice versa. So, physical conditioning allows us to improve strength and endurance, especially if we do hard exercises. Things like strength training, lifting weights, is really good for building muscle strength, mass, and then corresponding bone mass. So even as we age and our muscles aren't as strong as when we were younger and our bone density decreases, more problematic for females, exercise and strength exercise is very beneficial to maintaining our health. So a little on muscle terminology. Muscles attached to bone with tendons. Remember those structures of dense regular connective tissues, and the tendons are formed by the gathering of all the connective tissue sheaths in a muscle that merge together at the end of the muscles to form the tendons, which then attach to bone. So the terminology of origin and insertion. The origin is the site of attachment to the stationary bone, or the location, the attachment site that tends to move the least when a muscle contracts. The insertion is the attachment site to the muscle that, to the bone, I mean, that will move when a muscle contracts. So if you're lifting weights in the gym, you're doing curls or lifting a beverage to drink, the biceps brachii and something called the brachialis will contract, causing flexion at the elbow, raising the forearm and the hand. This is the muscle that's doing the movement, the work. This is the moving portion, the moving location. This is the stationary location. So the stationary location, attachment site's the origin. The moving attachment site is referred to as the insertion. So muscles can only pull, they can't push. So the single muscle can't both flex and extend the elbow. You need a muscle on the opposite side of the limb to do the opposite movement, in this case the extension. And that would be the triceps brachii. Okay, so movements, those we covered in chapter 8. Remember, flexion, extension, hyperextension, abduction, adduction, protraction, retraction, those sorts of things. So actions. An agonist, or a prime mover, is the principal muscle responsible for a particular action. So again, if we're doing flexion at the elbow, the agonist or prime mover would be the biceps brachii. An antagonist is something that works in opposition. So it's a muscle that opposes the agonist. In the example of flexion at the elbow, it would be the triceps brachii, which would be antagonistic to the action of the agonist, the biceps brachii. Now these roles are reversed with the opposite movement. If you're doing flexion at the elbow, the biceps brachii is the agonist, and the triceps brachii is the antagonist. But when you move to extend the elbow, now the triceps brachii is the agonist, the prime mover, and the biceps brachii is the antagonist. Okay? They switched roles because the movements, the actions are different. A synergist is a muscle that assists the agonist. So for example, the brachioradialis is synergistic to the biceps brachii. They both will work to flex the elbow. Most of the work's done by the biceps brachii, the prime mover or agonist. Then a fixator or fixators, these are muscles that will stabilize a particular joint to minimize movement. So if you are, say, working at the gym, lifting weights, and you want to focus on exercising the biceps brachii, you want to focus on this flexion at the elbow, you want to try to keep, or you want to keep your shoulder stationary. So things like the trapezius, the rhomboids, even the serratus anterior will flex and hold the shoulder and the scapula and the shoulder joint stationary while you focus on flexing the elbow. So those muscles will be fixators in this example. Okay, that's it for this chapter.